One of the most commonly asked interview question is to explain abstract class. Today we are gonna learn about abstract classes in detail. So let me create a new folder, abstract class. Let me create a new file of class type with the name base abstract class. Okay. So the first thing we have to tell the interviewer is an abstract class can contain abstract methods and non-abstract methods. Non-abstract methods are also called as concrete methods. And when we are creating abstract class, we have to use abstract keyword, right? So let's start with that one. Let me use abstract keyword. Next, we have to use like we can create this one abstract method. So this is an abstract method and it must be implemented by the derived class and it uses the abstract keyword. Let me rename it to base abstract method. You're also base concrete method. So let me use verbatim base abstract class. Now this is also called as this method as a default implementation and derived classes can override it if needed. Yeah, does not contain abstract keyword. Okay, let me create a new file derived class where we will implement this base abstract class. Okay, so let's remove entire code from your. Let's see, we will get compile time exception anyway, so we have to implement this all the abstract method. Here we will be using override keyword. We use override keyword to provide implementation of an abstract method. Now let me write this one. So this is the implementation of abstract method in the derived class. Okay, let's run this code and see what happens. Now let's see. So if we see this, if we go to this definition, it says this is the implementation of abstract method in the derived class. Exactly what we have overridden that abstract method, right? In the derived class, that method will be called. Now we are calling the concrete method, right? Concrete method are already implemented in the base abstract class, so we will be using that. Now let's dive deeper. Can we have constructors in abstract class? Yes, we can have constructors. Let me create a constructor. So I'm just writing this console light. This is a constructor of the base abstract class. Let me go to derived class. Of course, derived class can have constructors. So this is a constructor in the derived class. So one thing to note is first the base class's constructor is called, then the derived class. So let's run. So if we see, let me save this file. If we let's run it again. See, This is a base abstract class constructor and this is the derived class constructor. So yes, we can have so we can have constructors in abstract classes, which is not possible in interfaces. Okay, next let's dive even more deeper. Can we have can an abstract class inherit another abstract class? Yes, it is possible. Let's see an example. Let me create a new file, abstract class .cs. Okay, oh, just just keep abstract class. So here I want to implement base abstract class. So an abstract class that inherit another abstract class. So let me mark this as this with abstract keyword, right? So yeah, we are good. Now there are multiple ways. Like see, this is a constructor and I've created this abstract method within this abstract class and a concrete method, right? So let me save this. Let's go back to the derived class. Instead of inheriting the abstract class, let's inherit. Let me remove. Yeah, let me remove this one and abstract class. Okay. Again, we are getting this exception. Let's implement all. Yeah, this is what happens. We have to override abstract method and base abstract method. So let's see. Console.writeLine. This is the implementation of abstract method in the derived class. So this is the implementation of abstract method for abstract class for base abstract class. Okay, so let's go to this one. So let's clear it out. Let's call this one, and now what will happen? First thing, the constructor sequence. Derived class is using abstract class, right? Abstract class uses this base abstract class. So this constructor is first called, then this constructor is called, then this particular constructor is called. Following that, the sequence of this method implementation. So let's so what will be printed here? It will be printing like the method which we have overridden for both of them, and these are the concrete methods which are already defined in the base abstract classes. So let me run. See, we are calling base abstract class first, constructor first, then abstract class is constructor, then derived class constructor. Following that, this is the overridden method, right? This is the implementation of abstract method for the base abstract class in the derived class. Same. Now it is clear till now, right? Similar for concrete methods. It is very straightforward. Now comes the tricky part, upcasting. Let's learn about upcasting. So what we can do, instead of we cannot create instance. Okay, so we cannot create an instance for abstract class. So this is not possible. So instead of that, let me copy, let me remove this one let's write. Okay, let's keep it as it is. Let's comment it out. See, we will get this exception, cannot create instance of an abstract type or interface. Okay, but let's not create instance for that. Let's create instance for derived class and assign it to abstract class. So this is called upcasting. Okay, so whenever we create instance for the child class and assign it to parent, so this is called upcasting. So let's see. So abstract class dot um, this will call abstract class dot abstract method, right? And also abstract class dot base abstract method. And yeah, so I there will be no change in the output whatsoever right now because it is straightforward, right? So this is a constructor. We are just assigning the instance. Okay, and now let's do some changes. One more question: Can we override this concrete methods? Yes, it is possible. So let's keep this base concrete method as it is. Let's go to abstract class and let's name it as base concrete method. Note this one, like, and both names are same. Now see, it is telling that abstract class dot id inherited this one, right? So let's see what happens now. When I execute this one, will it call, when I execute base dot concrete method, will it call this one or the base abstract class? It will execute this particular method. So first thing, here we have to comment out this code, right? We forgot to do that. Right. If we see abstract class dot base concrete method, this is the concrete method in the abstract class, not the base class. Now let's do some changes. Let's, instead of uh, assigning it to this one, see, base abstract class does not know about this abstract method because it is not inheriting that one, so it won't recognize it. So let's see what will execute in this case. See, here we are this is straightforward. It is calling the base abstract class which is overridden, and this base concrete method here, this is the concrete method in the base abstract class. See, previously it was from the abstract class, now it changed to base abstract class. Now let's learn few more things. What happens if I use the new keyword? It remains same. It is just, it will do the same because we are assigning. Now let's see, override, and let's mark it as virtual, right? Now what will happen? Now it will, we are overriding that method, right? So whenever we override that particular method, even though we are assigning it to base abstract class, it will call the method concrete method in the base abstract class, in the abstract class, not from the base abstract class. Okay, and let's do um, one more thing. So I'm already having this base abstract method, right? Can I implement this base abstract method here? Right? Public. Now let's see what will happen. Same, no change, right? So this remains same. Now let's change it to abstract class. Now if we see here, whenever we are calling this method, right? So first one, it is same as it is, but here will it call the derived class abstract method or abstract method which we have overridden? It will call the abstract method which we have overridden, right, in the derived class. So let's remove this one because abstract class is already having base abstract method, right? Base abstract method, and in the derived class we have removed this one. So still we are not getting an exception because derived abstract class is already implementing that particular method. So even if I remove this one just for example, and if I do this one, it will only ask for to implement only one method, not two. So now let's run and see. See, previously it executed this one, right? The derived class. Now if you see in the abstract class, so yeah, this is how abstract classes works. Now let's see some real life examples. To summarize, abstract classes can't be instantiated directly. They let you define a mix of abstract methods and non-abstract methods. The beauty of abstraction class is sharing common contracts and behaviors among derived classes, while leaving room for them to provide their own specific implementations. Interfaces, by contrast, are pure contracts. No shared implementations, just definition for what members should exist. So how do you decide between them? Choose abstract classes when you want to share reusable logic like helper methods or validation across implementations. Go for interfaces when you are after pure decoupling like no shared implementation. Now, why do abstract classes work so well for notification systems? Think about it. Email, SMS, and push notifications all share common data like recipient, subject, and message body, plus shared behavior like formatting and validation. And abstract classes lets you centralize this logic while each channel implements its specific sending mechanism. For example, you define a notification abstract class with properties for recipient, title, and message. The base class provides a send method that handles validation and payload formatting. Delegating to an abstract method called sendCore. Subclasses like email notification, SMS notification, and push notification override this method to handle channel specific sending logic like building email MIME objects or integrating with push services. You have a notification manager that simply works with abstraction. calling send on any notification object and handling errors gracefully. Now let's see how we can use Notification Manager to send a push notification. To send a push notification, we need a push notification provider. Let's assume we have a Firebase push provider and we create instance for that Firebase push provider. And we create an instance for push notification which accepts device token, title, message and provider. Now we can simply create an instance for notification manager and send push notification object. So this is how we can leverage abstract classes, handle shared logic and for reusability. Thank you.